Now let's try and do example 15, question 1. We are given two functions, x and y, and there are parametric equations where t is not equal to 0. So we know that these two functions are parametric equations. And for question A, we need to show that dy dx is equal to this expression. So we know that to find dy dx, we need to apply chain rule. So before we do chain rule, find dx dt and dy dt first. So x is equal to 3t minus 2 over t. So in order to find dx over dt, we're gonna do something to negative 2 over t first. So change this so that you'll get kt to the power of n. And x is actually 3t minus 2t to the power of negative 1. So now we can differentiate this function. And you need to write this as a single fraction. So that is dx over dt. Now let's do the same for y. Y is 3t plus 2 over t. So change this so that you'll get kt to the power of n. So now we can differentiate y to get dy over dt. And we need to leave this as a single fraction as well. And we will get dy dt is 3t squared minus 2 over t squared. So to find dy over dx, we need to apply chain rule. So we need dy over something times something over dx. So what should we put in these spaces here? Since we have dx over dt and dy over dt, therefore, this should be dt as well. So now let's substitute dy over dt and dt over dx. dy over dt is 3t squared minus 2 over t squared. And next we need dt over dx. But if we look at our dx over dt, this is dx over dt, but we need dt over dx. So what is dt over dx? Okay, so since we have dx over dt, to find dt over dx, you're just gonna swap the numerator with the denominator. So that is why just now I said that you need to write your answers as a single fraction, so that it is easier for you to swap the numerator and denominator. And hence, dt over dx is t squared over 3t squared plus 2. And we're gonna substitute this into dt over dx. And note that we can cancel out t squared, which will leave us with 3t squared minus 2 divided by 3t squared plus 2. But if we look at our question, we need to show that dy dx is 1 minus 4 over 3t squared plus 2. But we have this expression. So we need to change this so that it will get this answer. And to do that, you need to do the long division. And hence, by using long division, we will get dy dx equal to 1 minus 4 over 3t squared plus 2. For question B, we need to find d2y over dx squared when t is equal to 1. So this means that we need to find d2y over dx squared first, and then you'll substitute t equal to 1 into d2y over dx squared. So just memorize the formula of d2y over dx squared using chain rule, which is d over dt of dy dx times dt over dx. So we need to find d over dt of dy dx. So for dy dx, this is dy dx. So you can either use this dy dx or you can use this dy dx as well. But in my opinion, this dy dx is easier for you to differentiate. So how do we differentiate 1 minus 4 over 3t squared plus 2 with respect to t? So this is t, this is also t. So straightforward, you can differentiate this expression. So I'm going to change this so that you'll get 4 times 3t squared plus 2 to the power of negative 1, because this is to the power of 1. And hence, when we differentiate with respect to t, let's separate this into two differentiation, like so. So now let's differentiate each term. Since 1 is a constant, therefore when we differentiate, we will get 0. And for the second term here, we need to differentiate this with respect to t. So 4 is a constant or your coefficient, so just copy them down. Since we have power, we're going to bring power to the front. Copy all the function. But now what happens to the power? It is negative 1 minus 1. But don't forget that you still need to differentiate the function with the power. So differentiate 3t squared plus 2 and we will get 6t. So now let's simplify everything here. And we will get 24t times 3t squared plus 2 to the power of negative 2. So this is for d over dt dy dx only. Don't forget about dt over dx. And we already know that dt over dx is t squared over 3t squared plus 2. So there's nothing for us to simplify here. So just copy them down at the function below. So now let's simplify this function with this function. And hence d2y over dx squared is 24t cubed over 3t squared plus 2 to the power of 3. But don't forget that we need to find d2y dx squared when t is equal to 1. So let's substitute t equal to 1 into t in d2y over dx squared. And the answer is 24 over 125. And that is how you apply parametric equations in order to find dy over dx and d2y over dx squared.